All right, this is Professor Papa J. Jacob Christ, and I've been working on the SoftwareSerial library for chipKIT. And if you're not familiar with SoftwareSerial lets you take any pin of your microcontroller and turn it into, or any two pins of your microcontroller and turn it into a serial port. And the way you do that is you create a SoftwareSerial object and you call it something like mySerial, and you pass in your pin numbers, and the first pin number is what will be your receive line, and the second pin number is your transmit line. And there's an optional third parameter that lets you invert the receive signal. So we've been working on some stuff where we want to do half duplex, or rather simplex serial communication. So we have one board that's going to be a transmitter and the other board that wants to be a receiver. So I had this idea of splitting the class into a SoftwareSerial RX and a SoftwareSerial TX, and then the idea was I would recreate the SoftwareSerial class as a child that has multiple inheritance from the SoftwareSerial RX and SoftwareSerial TX. Well, I've had some success at doing this. There was one little hiccup in that there's one variable that's shared between the RX and TX side of the class, as well as it's shared amongst multiple instances. So if you're going to instantiate multiple serial ports, that one variable is shared amongst all of them, and the way you do that in a class is make it static. And so I had to create a common, I called it a SoftwareSerial base. And so this base class, the RX and the TX both inherit from this as a virtual class, and virtual makes it so that only one instance of this class will ever be created, though I don't know that it really matters because the one variable that's in there is static, so it would only make one of those anyways. So now what's happened is there's essentially two functions in here, which are the write function and the flush function. And the flush function in Arduino 1.0 libraries is supposed to wait until all characters have been transmitted, until it returns. And the way the TX is currently implemented, this function doesn't actually do anything because the TX function is blocking and will not return when you issue a write. The write will not return until it's finished writing your values anyways. And then the RX side has available, read, peak, and I think there's one more in there, but essentially these type of functions are associated with the RX, and then the new child class that SoftwareSerial inherits these from the two simplex classes. Also, the other thing I had to do is these functions, available, read, peak, write, and flush, are all virtual functions that come from the stream class. So the SoftwareSerial originally inherited from stream, but now what I have going on is the SoftwareSerial base. It inherits from the stream class. And the stream class has these as virtual functions, and what it means to be a virtual function is that each one of these have to be implemented at some point along the way. So what I didn't want to implement write and flush in RX, and I didn't want to implement available, read, and peak over in TX. And so what I did is I actually implemented these functions, all these functions in this base class, and they actually do nothing in the base class. And so what that allows me to do is I could re-implement it over here in RX without having to implement flush and write, and vice versa for the TX. And then when I create the SoftwareSerial, I don't have to do anything. These just these just come along. So it'll get the software serial gets write and flush from TX and the available read and peak from the RX. And then the ultimate goal, what I really want to do is make another class that also inherits from these guys. It's a separate class. That's a soft. So these are software serial. Half duplex or something like that. Half duplex or just half. So these classes are simplex. They transmit or receive in a single direction only, and there's only one-way communication. This class, in theory, is full duplex. And the reason I say in theory is because it's got a receive and a transmit pin. Actually, can't quite see this. So software serial will have a receive and transmit pin. So in theory, it's full duplex, but in reality, you can only transmit or receive. You can't do both at the same time because of a limitation of the class currently. But in the half duplex, when we instantiate that, I want to instantiate it with a single pin that can both send and receive, and essentially it will always be listening until you issue a write, and then when you issue a write, it'll turn it into a transmit pin and transmit, and then when it's finished writing, it'll auto turn around back to receive and be able to receive. And the goal of doing this is so that the TX pin can be on an LED, and also through a tri-state buffer, the same pin can be on an RX to a photodiode. And what this will allow us to do is transmit. When we do our turnaround, we could transmit, turn the tri-state buffer to turn on the LED and transmit, and then when we're finished transmitting, it'll turn it back into receive mode, and we could receive data. So we could have a bidirectional communication using the same pin on the processor. And what this might look like with the tri-state buffers is something like this, where this is inverted, and this one may not be. And so this is your this is the common that goes to your RX TX pin on the processor, and then this becomes your TX, and this becomes your RX, and then this line over here controls. So TX would be logic low, and RX would be logic high on this tri-state buffer. And that's what I've been working on for the chipKIT software serial library. Yeah, my colleague here was asking me about trying to receive and transmit at the same time. So right now, the way the library works is when you transmit, it's using a timer in a blocking fashion, and blocking means that when you call the write function, so when you do a transmit and you write, that write function will not exit until it is transmitted one whole byte, or one whole frame, the start bit, the 8 bits, and then the stop bit. And the reason it doesn't exit is it essentially uses the core timer of the chipKIT. So it goes, what's the time currently, and when the class was constructed, or in begin or someplace, I think in the constructor, it must be in begin, because that's where you specify your baud rate. So in begin, it calculates the period of a bit, the time for one bit. And so when you transmit it, it says, what time is it now? And set my bit to whatever state I want it to be, high or low, and then wait until one bit period has gone by, and then it goes to your next bit, and it changes the state for your next bit. And so while it's doing this, the transmit it's hogging the whole processor. Nothing else is going on. And not only does it block, but it also, before it transmits, it disables interrupts. So no interrupt can occur while it's transmitting. So it hogs the whole processor, and it shuts off interrupts. So it starves any other thing that might want to interrupt the processor and prevents it from doing so. And so this is significant because the way the receive works, there's two ways you can receive with the software serial library. One is with interrupts, and the other is just polling the pin. So in the interrupt case, it uses change notice interrupts, and the change notice interrupt on a pin that has that capability will, when the pin state changes, it'll generate an interrupt, and then it could go in there and do some calculations and try to receive the data. In a polling situation, it would just go, oh, this pin can't or doesn't support change notice, so I'm just going to pull it when we go to do a read. And so we pull it, and we sit there and we look at the state of that pin to see has it changed, and if it has, how much time has gone by, and where am I at in the sequence. And so in either case, interrupts or polling, with interrupts when you're transmitting, we've disabled the interrupts, and with polling, when we're transmitting, we're hogging the processor. So the processor can't sit there and look at pins. So that's why I said the software serial is in theory full duplex, but in reality, it's not full duplex. It's kind of a pseudo full duplex. You have a transmit and receive, but you can only ever transmit or only ever receive. You can't do them both at the same time. So I think there's probably a path to using some kind of timer to transmit using interrupts, so that the write function doesn't have to block. And if you could do that, then both the change notice and the polling receive would work without probably without modification. But that may be a task that I'm not willing to take on at this point. So, did you have any other questions about it?
Yeah, that was it.
All right. So where the simplex might be useful, or will be useful, is since you cannot do true full duplex communication with this, where the simplex would be very useful, or the software serial half duplex class might be very useful, is in this situation where you are using an LED, and you would only ever be transmitting or receiving, never both at the same time. So that's the goal. Whether we get there or not, it's another story. So my colleague here had another question. So he said breaking into two classes didn't give us full duplex. No, it doesn't give us two full duplex. It gives us two simplex classes. They're neither half duplex or full duplex. They're simplex. Simplex being communication in one direction only. And so the reason for splitting them, the original reason for wanting to split them, was so that we could not have to dedicate a pin to a receive or transmit function if all we were doing is transmitting or all we were doing is receiving. And you know, I guess we're having this issue where we're doing some we're trying to use the pins for both digital levels and serial communication, and we're having the processor lock up or something. Wasn't So the processor was locking up when we were doing digital writes, and so there might have been some conflict with the library. So my first thought was, well, let's get rid of whatever's transmitting and receiving, right? Let's just we're going to receive right now, and then we receive, and when we're done, we shut that class off, and then we use it a transmit or whatever. So ultimately, I don't know if this is any better, but we certainly have more flexibility than we had before. Oh, and the other nice thing I implemented, but it hasn't fully tested, and we'll try to test it today, is in the simplex transmit class, you now have the option of inverting your transmit. And the reason that was important is because the way we had our LEDs wired is the LEDs were always on, logic high, your mark, when you have your idle line in serial communication, you're just sitting at a constant voltage level. Well, the way the transmit class was written, that constant voltage level is a logic high, and our logic high was hooked up directly to our LED, so our LED was always on. And so that wastes power, but also if we had a misalignment, it would cause the receiver to see, as we're trying to align it, you might get spurious start and stops, where if normally our idle line is no light at all, when you're aligning you don't get any spurious communication, and then when you go to transmit, your start bit is actually, it's a logic high, and so your whole serial communication is inverted. And so that was another goal, and so I have achieved that. And talking to Brian Schmalz, who's worked on this library, he is not sure if the receive line, there's an option to invert the receive line. He's not sure if that's working, so we could test that as well today. And so I was trying to test that yesterday by doing a loopback, by hooking the transmit up to the receive, and because of the problem with the full duplex that I just described, it wasn't working. Right? And that's how I figured out this whole issue of, oh, it's not really a full duplex class. It's kind of half duplex on 2 lines. And what would be really cool is to get a half duplex on 1 line, so that we could, the way we have our photodiodes and LEDs wired, we could use 1 pin and instantiate 1 class. And it might also be nice to, there's some features in there. There's a end command, so there's begin and end. And the end on the receive is supposed to disable the interrupt and remove it from the interrupt list, and I don't know how well that works. And so it'd be nice if you could say begin, do your transmission, and then end. Use the line for something else. Do begin again, end your transmission, and or so you could turn it on and off at will. Would be really nice. And so. We'll see about that. So one final comment as we were talking after I set up the camera. So when I was playing with the library yesterday, I created a loopback on my serial. So my SoftwareSerial transmit I tied to my SoftwareSerial receive, and I was trying to send data out to transmit and listen to it back. When I did that, 1 byte would transmit, and then the whole thing would lock up and nothing would work after that. And what may be happening is, because the transmit function blocks and the receive function may or may not be using interrupts. I think it's probably using interrupts on the chip I was using. I was using a Fubarino Mini, and because of that, we might have got a single interrupt as the transmit line finishes, right, or something, or maybe interrupts are disabled and some transitions occur, and in the processor there's a flag that says, an interrupt has occurred, but because it's masked, the interrupts are disabled, it doesn't actually fire. But a flip-flop inside the processor has been set that indicates a change has occurred, and so when the interrupts are re-enabled, that interrupt fires. And when that interrupt fires, it goes, there was a transition. We've got our first bit, and now the class gets stuck because it doesn't receive all the bits. And so if that's really what's happening, there may be other issues that we need to deal with, like if we receive a few bits or something and we don't receive all the bits, it should time out. Actually, that doesn't make a lot of sense, because it should no matter what, when it receives the first transition, after 10 bit periods, it should go, I either have a framing error, or the garbage that I received was this. So clearly there's something locking up the library, and it's probably on the receive side, and I'm not sure if it's. So I was using pins 10 and 11 of the Fubarino Mini, and it may be. It seems like every pin of the Fubarino Mini has a change notice interrupt capability, but I'm not 100% sure of that. That's just glancing at the code. And I guess the other thing too that's important to note, as of this recording on what are we, July 7th, 2016, the software serial library works with the Fubarino Mini. I tried it with the Fubarino SD and got all kinds of compile errors. And from some notes and comments I saw in the issue tracker on GitHub, it may be that it may only work with the Fubarino Mini. It may not work with any other chipKIT board at this point in time, or any other, the way the issue was stated, any other PPS chip, any chip that was a non-PPS chip. And PPS are the peripheral select, where you can, there's a matrix inside the processor, and you can move pins around. So you can make you could put your interrupts on any pin, or you can make any pin within some limit, the hooked up to your hardware UARTs, which is a really cool feature, or SPI. So you could move where the SPI is, or the UARTs are. And I imagine that's a type of a feature that maybe someone built a million boards, and they screwed up, and they went to Microchip and said, we screwed up, fix the chip. I don't know. I don't know how that happened, but it's a really cool feature. Thank you, Microchip.